For almost all of human history, machines did not move. Think about that for a second. They were anchored, bolted to the ground, fixed inside workshops. They were bound to rivers, the wind, or massive steam pipes. Motion the ability to travel across distances that belonged to animals. Horses pulled our carts, oxen dragged our plows, and human or animal muscle carried every single weight. Machines could transform force, sure, but they didn't travel. Even deep into the Industrial Revolution, this fundamental division remained untouched. We had powerful engines. We had harnessed the power of steam. We could make things spin and rotate. But actual movement, getting from point A to point B, was still a job for living creatures. The steam engines of the era were monstrous. They were massive, heavy beasts that required a constant supply of water and fuel, and a team of people to supervise them. They vibrated violently, they leaked, they often overheated. These were not machines you could just pick up and take with you. They stayed exactly where they were built. The very idea of a machine that could move itself was considered impractical, even dangerous. And it wasn't because creating motion was impossible. It was because controlling it was a self-moving machine would have to solve problems that no workshop machine had ever faced. Things we take for granted today, like balance, steering, and changing speed. It would have to handle uneven terrain and, most importantly, it needed to be able to stop safely. A factory floor is flat and predictable. The world is not. For centuries, the only reliable solution to these problems was an animal. By the late 19th century, engineers had become masters of stationary power. They knew how to generate immense rotational force, how to transmit that torque through gears and belts, and how to control the speed of their factory equipment with incredible precision. But they had never successfully combined all of this knowledge into a single mobile system. The real challenge wasn't about achieving speed. It was about achieving autonomy. The world needed a machine that could carry its own power source, regulate itself, respond instantly to a human operator, and somehow survive the constant bone-shaking vibration of travel. Nearly all of the early attempts failed before they even moved an inch. The engines were simply too heavy, too unstable, and too violent in their operation. Steam power, for all its might, in a factory or on a locomotive, just couldn't be scaled down reliably for a small vehicle. The boilers were prone to exploding, the pressure fluctuated wildly, and control was sluggish and imprecise. What was needed wasn't just more power. What was needed was a completely different kind of machine, a compact engine, a controllable engine, an engine that could start, stop, and vary its output almost instantly. This is where internal combustion entered the picture. It offered that possibility, the dream of a small, manageable power source. But a possibility is not a machine. To actually work, everything had to be perfectly integrated. The engine, the transmission, the chassis, the steering, and the brake system depended on all the others. A failure in any one part meant total failure of the whole vehicle. It was a chain where every link had to be forged from scratch. This brings us to Carl Benz. What he did was so much more than just inventing a car. He attempted something far more difficult. He attempted integration. Instead of trying to build a better horse-drawn carriage, he set out to build a machine that just happened to have wheels. His first motor was tiny, but it was violently inconsistent. Every single detail mattered. The ignition timing had to be perfect. The fuel and air mixture had to be just right. The engine had to be cooled constantly. Every vibration from the rough roads threatened to shake the entire machine to pieces. And yet, it worked. For the very first time in history. A machine carried its own power and moved through the world under its own control without the help of animals. The Benz patent motor wagon of 1886 certainly didn't look like the future we know today. It looked fragile, almost comically underpowered, and incredibly uncertain on its 3 spindly wheels. But it crossed a boundary that no machine had ever crossed before. It moved itself, and in doing so, it didn't just create a new type of vehicle. It fundamentally changed our relationship with distance, with time, and with the world itself. That single, hesitant journey was the start of it all. When we think of the first car, we imagine a clunky, slow machine, a curious novelty. But that's a mistake. The first car wasn't a failure of speed. It was a profound triumph of control. Think about it. Every single part of Carl Benz's motor wagon already existed in some form. Engines existed, wheels existed, gears and transmissions existed. They were all separate pieces of technology humming away in factories or workshops. What didn't exist was a system that could make them all work together harmoniously while in motion. The real challenge wasn't just creating power, it was taming it. An engine produces raw, violent torque. If you hooked that power directly to a set of wheels, the machine would simply tear itself to pieces. It was useless energy. That torque had to be moderated, transferred, and delivered smoothly. So, a transmission wasn't just for changing speeds, it was a mechanism for survival. The vehicle had to be able to start from a complete standstill without lurching into oblivion. It needed to climb hills, turn corners without flipping over, and, crucially, stop without self-destructing. Every element we now take for granted was a life-or-death engineering problem. Steering wasn't a minor detail. It was existential. At the crawling speeds of the first cars, instability was a constant battle. A slight turn of the tiller could send the vehicle veering off course. Go any faster, and control would simply vanish. The braking systems were terrifyingly crude. Often just a block of wood pressed against a wheel, relying entirely on friction and the driver's desperate judgment. Every single journey was a high-stakes experiment in physics and mechanics. So why did this imperfect, dangerous machine eventually replace the horse? It wasn't because it was better. A horse was faster, more reliable, and could navigate rough terrain with ease. The car replaced the horse because it was independent. It didn't need to be fed or watered. It didn't get tired on long journeys. It didn't panic at loud noises. But it demanded something entirely new from its owner: constant maintenance, precision, and a deep understanding of its inner workings. This was a revolutionary moment. For the first time in history, a complex machine left a controlled environment of the workshop and ventured out into the unpredictable real world. It faced dust, mud, rain, scorching heat, and freezing cold. The pristine conditions of the factory were gone. The automobile forced engineering to confront reality head-on. And when things went wrong, the failures were immediate. They were public, and they were often incredibly dangerous. And yet, despite all these flaws, the concept survived. It survived not because that first car was a roaring success, but because it was possible. The moment a machine proved it could move itself under its own power, there was no turning back. This singular achievement changed everything. Power was no longer static. It became portable. Industry was no longer confined to the factory walls. The very concept of distance began to collapse. The first automobile wasn't just a new type of vehicle. It was the world's first truly autonomous mechanical system. It was a machine that carried its own power source, converted that power into controlled motion, and made dynamic decisions based on human input. The throttle, the brake, the steering wheel, these weren't features of comfort. They were the essential mechanisms of survival, the interface between human intention and mechanical chaos. From that moment forward, the entire field of engineering had to reorient itself. Mobility could no longer be ignored. Machines were no longer just static tools bolted to the floor of a factory. They became active participants in the world, and the world had to adapt. Factories started to follow the machines. New infrastructure, roads, gas stations, repair shops sprang up to support them. Entire cities began to reshape themselves around the logic of the automobile. So, the car didn't just change transportation. Its first and most profound impact was on the priorities of engineering itself. Reliability, durability, and above all, control under motion. These became the defining challenges of modern mechanical design. The first car was slow, it was fragile, and it was dangerous, but it proved something irreversible. Machines no longer had to stay where they were built. They could move. And once our machines learned to move themselves, the shape of human civilization was altered forever. Thanks for watching. If you enjoyed this, look into the history of technology. Consider subscribing for more stories like this.